Hey guys, it's Miss McCorn. Hope y'all are having a very good week so far. What we are doing today is Unit 4, 4.5 Stoichiometry, predicting the mass of products and reactants, limiting reactants, and percent yield. This will be a review from the last quarter, so hopefully you'll know how to do most of this stuff, and all we'll do is a bunch of example problems. It may run a little bit longer than 10 minutes, but if it's something you know how to do, you can fast forward through pretty quickly. I'll also leave a few links on the Edpuzzle for extra example problems with Tyler and Melissa Maribel. That way it'll give you some extra practice if you need it. So take a minute to pause the video and write down in your own words learning targets. And my suggestion is to work these problems out with me on your own paper so you can have these as you need them. Alright, so our first problem is what mass of water is produced when 246.6 grams of methane is burned in excess oxygen in its gas form. So your first step needs to be to write down the balanced chemical equation. Okay, so that's always going to be your first step. If you're not given the balanced equation, always first write it down. So here's our balanced chemical equation. Okay? So the next thing that you need to do is convert or find the correct units. You're always going to start with the given. Okay, so always start with the given. In this particular case, we are going to start with, not good at this yet, we are going to start with this 246.6 grams of methane. So when you start with that, always write down your given, and I've also told you guys always make sure that you write down your units and make sure you write down what you have. Your substance. So 246 points. I wrote this down wrong. It's supposed to be 246.4. I apologize, guys. So 246.4 grams of CH4. We're going to first convert that to moles because we want to go from grams of methane and we want to find out what the mass of water is. So we want to go from here all the way to here. So first we have to get from moles of CH4 and then get all the way to moles of H2O, and then convert to grams of H2O. So to do that, first we go grams to moles, and we are going to need the molar mass here of CH4, which we use the periodic table, add it up, and we get 16.04 grams of CH4. Okay, and that's for every 1 mole of CH4. Then we're going to do our mole-to-mole ratio. For every 1 mole of CH4, we have 2 moles of water. Now, how did I get that? Remember, I said I had to use our balanced equation. So here is my 2 moles of H2O for every 1 mole of CH4. So that is my mole to mole. Now, you may ask, why did I put the CH4 at the bottom? That's because I need to cancel out my moles of CH4, so that needs to go at the bottom. Continuing on, I'm trying to convert from moles of water to grams of water because my question asks me how many grams, what is the mass of water? So I want to go to the mass of water. So for every 1 mole of water, and again, I'm going to use my molar mass here, and I know that my molar mass of water is 18.02 grams. And then I'm going to have my answer, okay? So I'm just going to put this in my calculator. Once I put this in my calculator, I am going to get 553.6 grams of water. And this would be my final answer, noting that I have both my units and I have the substance. Alright, so since I don't want this video to be super duper extra long, I'm going to go ahead and move here to example 4 to do limiting reactant example. What is the limiting reactant when 28 grams of glucose reacts with 14 grams of oxygen gas? What mass of CO2 is produced? Again, step 1 is to write the balanced chemical equation. And we have that right here. Step 2, in a limiting reactant problem, you must first find the amount produced by each reactant. So that's the first thing we're going to do here. So we're first going to find how much of the CO2 is produced when we have 28 grams of C6 of glucose. Okay, so we have 28 grams of glucose. And we're going to see how much CO2 is produced. I don't know why I put a plus sign there. I apologize. So we're going to multiply that, and we're going to use its molar mass, which is 180.18 grams for every 1 mole. And then we're going to do our mole-to-mole ratio. For every 1 mole here, 1 mole of C6H12O6, or glucose, we have 6 moles of CO2. Remember, we're trying to get from glucose to carbon dioxide because that's what our question asks us. What is the limiting reactant when 28 grams of glucose reacts with 14 grams of oxygen and CO2 is produced? So I want to know which one of these is going to limit my CO2. So I need to know how much CO2 is produced. So for every 6 moles of CO2. So now I'm going to have to convert to grams of CO2. So for every 1 mole of CO2, again, I'm going to go to my periodic table and find out that my molar mass of CO2 is 44.01 grams. Okay, and once I put all of this into my calculator, I find that I have 41 grams of CO2. Moving on, I need to use my 14 grams of oxygen because I need to find out what's my limiting reactant. What is going to produce the least amount of CO2? So I start here with 14 grams of oxygen. We're going to do the same process we just did up here. So for every 1 mole of oxygen, I know from the periodic table that I have 32.00 grams of oxygen. That's my molar mass. For every 6 moles of CO2, I have 6 moles of O2. I probably said that backwards. I apologize. For every 6 moles of O2, I produce 6 moles of CO2. Apologize for saying that backwards. Okay, and then I am going to multiply again by the molar mass for every 1 mole of CO2. I don't have to recalculate that because I already calculated up here 44.01 grams of CO2, and I get 19 grams of CO2 once I put all this in my calculator. I'm going to remind you guys, and I know we've done this before, but I want to show you how we have crossed everything out. We've canceled out our grams of O2 here. Those cancel out because I'm dividing, and then my moles of O2 dividing, my moles of CO2. And then I end up, the only thing I have left is grams of CO2. That's why I end up here with these things. So the next step here to find my limiting reactant is to compare the two masses produced. The reactant that produced the smallest quantity of product is the limiting reactant. So whatever produced the smallest quantity is the limiting reactant. So this is my smallest quantity, therefore oxygen is my limiting reactant. Okay. Now, this asks another question. What mass of CO2 is produced? Pretty easy, right? Is it going to produce 41 grams of CO2 or 19 grams of CO2? Well, it's going to produce only 19 grams of CO2. So this is part A. Part B, it's only going to produce 19 grams of CO2. I can't produce 41 grams because I'm not going to have enough oxygen to make that happen. All right, very quickly to find the percent yield. If we only had 15 grams actually produced in the lab, we just do very quickly actual yield divided by theoretical yield times 100%. Our actual yield would be our 15 grams of CO2. We would divide that by our theoretical yield,